a survivor. This is our last one of proofs. We're surviving the chapter on proofs. If you made this far, you're killing it. Last section. Let's do a proof. Don't write this one down. This one's just to get us in the mood for proofs and, again, why they're important. So check this out. I got, obviously, we always start with a given at this point. We said that Sully is what? Greater than Kelly? And that's a given. That goes back to, remember, last time we proved that Mr. Kelly's lame. We could do a more in-depth proof of that, but it's given, so we're not going to have to spend time on that. So we know that Sully is greater than Kelly, or better than Kelly. Then if you look at the age of Brust is greater than the age of Sully. So that is another statement here. That is definitely true. And if you look at that, I'm 36, and he is 35. So I'm 1 year older than him. So obviously I'm better than him in that regard. So we've got that going on. And then if we look at this, how do we know if the age of Brust is greater? If Brust is better than Sully, and Sully's better than Kelly, then what do we know has got to be true? Well, we know Brust is better than Kelly. And how do we know that? That is the transitive property. Remember that? If A equals B, B equals C. Transitive property. When it says if A equals B, B equals C, then A equals C. Same thing with inequalities. You know, if Sully's better than Kelly, Brust is better than Sully, then Brust has got to be better than Kelly. So I've got the transitive property show that I'm better than Sully, I'm better than Kelly. Also, if you look up here, you know, mark the picture. Look at this dude right here sporting the Algebro t-shirt. So I'm going to look at this Algebro photo up here. And the reason this is important is that I'm not that guy. Because look at that dude. He's definitely not the coolest Algebro I've ever seen. Look, the stash is pretty sweet, actually, though, and I do like the shirt, but I'm not that guy. So I showed them better than Kelly, I'm better than Sully, and I'm not that dude there. So what? Then I know what Brust has got to be the coolest Algebro. He is the coolest Algebro. And what is the reasoning for that? Let's go back up here. We have SAA, or what is this? Angle, not angle, angle side. AAS is why I'm the coolest. And I've worked in a real geometric property. That is awesome. Fantastic. All right, so let's do another round of proofs. We only got one more thing to do in this one. All right, so what are we doing in 4.4? 4.4, we're really doing the same thing here, just adding one extra little piece to it. And you maybe saw at the top, this CPCTC, corresponding parts of congruent triangles are congruent. So really what we're going to do is we're going to prove two triangles are congruent like this. In this case, it's given that RTS is congruent to TRG. So I can match them up and say, oh yeah, this matches this matches this. But we're going to prove two triangles are congruent by, remember, our same things we have, you know, side, 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 angle, side, angle, side, angle, or angle, angle, side. We're going to use one of these things to prove them congruent. And then we're going to say after they're congruent, SR is got to be congruent to what? Well, match them up. SR matches GT. So I know these are congruent. So it actually goes back to like 4.1, like corresponding parts. So really all we're doing is adding 4.1 back into the mix and saying corresponding parts. Excellent. So let's try this in a proof. So right off the bat, we've got this going on. Again, so definitely I like to mark the picture when I start. So I've got XJ is congruent to HI, so they're congruent. I also know XJ is parallel, so draw this little arrow. It's parallel to IH. So that's cool. That's going to help us out. What are some things we know here? Well, that was all given to us, and I also know some other things. I know this is in both triangles, and it's weird. Look at the proof. I'm not trying to prove two triangles. I'm trying to prove XH is congruent to JI, so it looks like it. So I'm going to prove this triangle is congruent to this triangle, and then do it. So this is a good start. I have this going on. What else do I know? Why did they give me parallel lines? Well, they gave me parallel lines because of this. I got parallel lines cut by a transversal. What do I know? I know these alternate interior angles. So really, this angle is congruent to this angle because they're parallel. So they're parallel. So why are the two triangles congruent? I have side, angle, side here. But that's not it. My goal is to take it one step farther. After I'm going to congruent, I'm going to show that missing side must be congruent. Excellent. So let's do it. So number one, given. I went ahead and copied that down for us. So it's given. And in this given, I already have shown one side. So I'm looking for side, angle, side. Let's go ahead and address that angle right now. I'm going to say angle XJH is congruent to, what is that, JHI. And how do I know that? Because alternate interior angles are congruent. Excellent. So they're parallel, they're alternate interior angles, and they are congruent. So I took care of a side. That is my angle. What's my other side? Well, I know JH is congruent to JH. And what is that? That is the reflexive property. So we've seen that guy before. Fantastic. And then I'm looking for, now I can prove the triangle's congruent, and be real careful with naming them. I'm going to name them correctly. So I got to say, let's call this JXH. So you can name the first one however you want, but now you got to match them up. J matches what? J matches H. I know that for sure. And then what's next here? I want J to X, so this is going to go H to I. And then to J. So I proved these are congruent. How did I prove them congruent? Well, remember in the first one I showed, here's a side, part of my given. I proved this angle, and I proved this side. And that my whole goal here was side angle, side. There it is right there. So all I'm going to do is add one more step to this. I proved these two triangles are congruent. Now I'm going to go ahead and say, well, if they're congruent, I know XH is congruent to IJ or JI, however you want to write it, it's okay. Why? Because of CPCTC, corresponding parts of congruent triangles. This side must match this side only because I proved the triangle's congruent. Can I say that? CPCTC. I love it. Excellent. Alright, when I finish these, that's fantastic, especially a long proof like this. I really like to have a big celebration. Here's the celebration dance. Check it out.
Oppan Gangnam Style. Gangnam Style. Op, 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 op. Oppan Gangnam Style. Gangnam Style. Op, 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 op. Oppan Gangnam Style.
Very good. So that's the only one little thing we're adding on here. Also, we're going to add a hypotenuse leg. Do you remember back when we did angle side side and we said no way that works? Can't cuss in math class. Well, it turns out there is one time we know it definitely works. How do we know it works? Well, if for some reason you are given a right angle here, and you know this side, if I have this, and this, these must be congruent. This is a time when angle side side must work, because I can't swing it and have it, come into the other side like I was swinging the leg before. Can't happen. There's a right angle that has it fixed. It's going to touch exactly one time. So angle side side doesn't work unless what? Unless this A is a right angle. So if you have this situation, you can say HL or hypotenuse leg. I know, this is a right triangle. I know this is the hypotenuse, and I know this is a leg, one of the sides. Just like this is hypotenuse, this is leg. We have either leg, but you need to know one leg, one hypotenuse, and then you're good to go. So a hypotenuse leg. So if you have that, it's another reason to prove them are congruent. Fantastic. So can we do a proof with this? Yes, let's check it out. We know I'm given some right angles, which are already marked. Then it's giving me a bunch. HY is congruent to EL. HP is congruent to LG. So here it is right here. Why are these congruent? It's not angle side side. That doesn't work, but it's a right angle. I can say hypotenuse leg. Look at this one I'm trying to prove. Hypotenuse leg. Very clever, Mr. Brust. So this is a big given. Let's look at the given. I wrote it for you. Boom, there it is. Got the given. In this given, did it tell me some stuff? It sure did. It actually told me HP to LG is the hypotenuse. And it actually told me HY to LE is a leg. So we have the H and the L. What am I missing? I got to make sure it's a right. This only works for right triangles. So you got to say it is a right triangle. So you have to say triangle hype and triangle leg are right triangles. Ooh, I need more space in there. They are right triangles. And why are they right triangles? It's the definition of right triangles. So that's a little triangle sign there. Definition of right triangles because they have a right angle in them. So once I show that they're right triangles, then I can go ahead and say, oh yes, they must be congruent. HP is congruent to L to leg. My handwriting's a little rough today. L-E-G. And why is that? That's hypotenuse leg is the reason for that. Fantastic. So really, all right, good luck on the mastery check. I hope it goes well for you and dig these proofs. Peace out.